Hello. In this lecture, we are going to continue towards our goal to crack the login. And our next step is to figure out how the password is checked. Of course, from here, it's not rocket science to figure out how to proceed. You could do the same thing what we did with the username, but for the sake of learning, we will choose another approach. So we start Radari again, analyze. Whenever you do something and you don't receive the results what you're expecting in Radari, then check whether you did the analysis or not. Usually that's the problem. So this approach will be to look into the strings and try to find something password related. So if you remember, we could print out the strings in the binary with the IZ, but it was pretty much. So what we could do is we could grep it with the tilde. I showed it already. And we could search for password, but I'm going to search for S-word, not because I like to say S, but because the P might be capital or not. And since we don't know, I'd rather look for S-word without the P so that we cover both cases. And we got a couple of results. So we've already seen these, or no, we've seen this. If you go back to the logs, you know that we write reading username when somebody tries to log in. Now these are the interesting things. There's a log string password correct, and there's a log string wrong password. So this could be interesting. And these are in the RO data section of the binary, and it's ASCII. And here is the virtual address of the string in the binary or in memory when it's loaded in memory. So what we want to find out is where is this string used in the binary. This is a really important technique when you're reversing to find elements in the binary, what you're seeing, like whatever you want to do and whatever you want to figure out how it works. You need to search for things which you see around that part you want to reverse, because you need to find it in the binary where those things happen. So this approach is to find a string and see where this string is used in the binary. Now this is called cross-references. So we want to see from which line of the assembly code this memory address is referenced. So this command is under analyze. And here there is the AX manage refs and xrefs. So let's do AX question mark. And here it says find data code references to this address. This is exactly what we want to do. So we'll do AXT. And then we copy the memory address there. And this tells us that this line from the check password function at this memory address, and this is the assembly code. This is just a label or a reference to that address where the string is. This is just created by Radari. So that's one way. So this is the address where we need to go, but I will show you another way. Instead of using AXT, I will search for passwords again, and then I will jump to this address and print the disassembly 10 lines from here. So PD is print disassembly. We have seen it in the PDF command to print the whole function. We don't want to print the whole function right now. We just want to print 10 lines, and $$ marks the current location where we are standing in the code. So we're gonna print out 10 lines from here. This is basically where this string is stored in the binary, and Radari tells us a lot. So this is the label, how this string is referenced in the assembly code created by Radari. And it also says that there is an xref to this address from here. And if we scroll a little bit back, this is the same address what we found out. So this is just two ways to find the same thing. Where is this string referenced in the code? I showed the second technique because sometimes this ext did not work for me. So for instance, I tried it with MIPS binaries and for some reason it didn't work. So in that case, you could use the other technique. All right, so let's go to that address where the password correct string is used. So I will seek there and I print the whole function. And this is the check password function. And if you look around here, it prints the reading password log message. So probably here is our input read. It prints the log message, then does something. At this point, there is a string compare. So that's really interesting for us. And from here on, it's more or less the same what we did in the previous lecture. There's a string compare here. Probably one argument is the input string, what we type in, and another argument is the password that it expects. And here you could see that it does a similar thing what we've seen with the username. So we could check out what these values could mean. I will actually print this again just to have better look. So I will do PD and 10 lines at this address. I will just print it here so that I don't have to scroll up and down. So you can do question mark and this value, this says solo, then question mark and this value is my question mark and this value is my bit. There's an IH here. So I guess Jabba really does not like solo. But anyway, let's try whether we are right or not. So I'm already running the application here and I will connect to it again. If you remember, username was Jabba. And what we think now is that the password is solo is my P asterisk TCH. And it worked. So apparently that was really the password. And what happens here is that it says your password's my master. So apparently this application is some kind of password safe for Jabba. But you know, if you start looking at it, Netflix, Tinder, Shake That, Rancor's Cage, Kitty1234, Fortune, you know, even though we reached our goal to crack this application and see what's stored there, it doesn't really seem to be helping out the rebellion. Of course, you might want to check out Jabba's Tinder profile, but I don't really recommend that. You know, you can see it, but you cannot unsee it. So our goal is reached, but it didn't help us a lot. So I guess we have to keep investigating in the binary. And that's what we're going to do in the next lecture. So I will see you there. Until then, take care. Bye.